So, these are what we're looking at today. They look a whole lot like ones we did last week, but they're not the same thing. Because last week we were focusing on arc degrees and angle degrees. And that's when we did arc plus arc divide by 2 equals angle. So we were focusing on the degrees of everything. Now we're focusing on the segment lengths. So we're focusing on just the segments, nothing to do with degrees, just the segments. Which means I kind of really need to give you a definition or a term for these segments, because we're focusing on segments now. So that's where I'm going to start. So those are called chords. So chord. A segment that connects the two sides of a circle. Now, yesterday we talked about diameter. Diameter is a type of a chord. Diameter goes from one side to the other, but has to go through the center. Diameter has to go through the center. A chord just goes from one side to the other. It can be a really, really tiny chord that just kind of cuts off a little sliver of a side. It could be the entire half, like a diameter, but it just goes from one side to the other. Chord. So what I need you to do, yes, you're getting a lot of practice drawing circles. So draw yourself a circle here. And you're going to draw two chords. Try to make sure they don't cross exactly in the middle. Kind of put them off to a corner. And be really, really careful when you're marking this. So you're going to take one chord, and notice this chord got put into two pieces. Mark one piece as an A, the other piece as a B. And it doesn't matter which one's which. Just make sure it's on the same chord. And then the other one, this chord got put into two pieces. Put one as a D, one as a C, one as a D. And like I said, it doesn't matter which one's which. So I have two chords that are intersecting inside the circle. Two chords intersecting inside the circle. And like I said, these chords, I mean, they could just cut off a tiny little sliver here. They could go nearly across the circle. It just has to go from one side to the other. My formula for solving for any one of these four positions is A times B equals C times D. So you end up multiplying the two pieces of the chord together. Set equal to, multiply the other two pieces of the chord together. That's your set. It will equal the same thing. So does everybody have that written down? So let's look at some examples. Like I said, I've only got 4 on the front that I'm doing, and then the back 4, what you're going to do. Hopefully you'll be able to just do them in class real quick, and then we'll just move on from there. I like starting with the X. I just do. So you're going to multiply the two pieces together. So make sure you're on the same chord, 18 times X, which is just 18X. Then you're going to multiply the other pieces of the other chord, which is these two, 16 and 9. And let me put a parentheses. 16 times 9. That's it. Now you just solve the algebra. This one's a pretty easy algebra. Some of them can get a little harder though. So 16 times 9. You'll find that I really liked 144 on this worksheet and the next worksheet. You get a lot of 144s. Divide by 18. I get 8. Dang. So this little little guy here is 8. Now, actually turn on that little quizzies thing. I had a lot of people, the question that looked like this, I had a lot of people that got it right. I'm not sure how many people actually knew the formula. Did you know the formula?
No.
But I think you just guessed it right because the number's given.
Yeah.
So because of the numbers I gave you as choices, I had a lot of people get the right number. Mostly because there was only really 2 that even made sense. And I think I got about 53% that figured out the right one. But now, hopefully, you know how we actually got that number, as opposed to making a really good judge based on sizes, which isn't a bad way to do things, but we need to know the formula. So that was number 1. Are you all right? Number 2, same thing. Multiply the 9 and the x together, 9x. Multiply the 6 and the 15 together. Doesn't matter which one's first because it's multiplication. So you can do 15 times 6 or 6 times 15. Won't make a difference. And what is 15 times 6?
100.
Yeah, let's try again.
105.
Let's really try again.
90.
90. There we go. So 15 times 6 is 90. Divide, you get 10. So this segment here, we get a 10. So that was number 2. So 1 and 2 had the easier formulas. Are we okay on 1 and 2? 3, 4. Well, now they just get a little harder, but your setup hasn't changed. You're still going to multiply the 2 pieces of the segment, multiply the 2 pieces. They both have an x. Which one do you want me to start with, the 5 or the 4?
Go 5.
So 5, make sure the x plus 1 is in parentheses. X plus 1. Same with going this way, 4, x plus 3. There's my formula. Distribute the 5, distribute the 4. So 5x plus 5 equals 4x plus 12. Get my x's together. Subtract 4x. X plus 5 equals 12. Move the 5. X was 7. So I'm not saying the segment was 7. I'm saying I plug 7 back into the x. 7 plus 1 is 8. 8 times 5 is 40. Put 7 in here. 7 plus 3 is 10. 10 times 4 is also 40. So I'm not saying the segment is that number. I'm saying that the x that I could plug in is. You okay on 3?
Mm-hmm.
Number 4, a little easier of an equation. Multiply, multiply. 6x plus 2. 9x. Distribute. Move the 6x. And I get 4. Now, the back 4. I'm going to give you about 5 minutes. If you don't get done in the 5 minutes, not a big deal. You can still finish later. That little poster there. Go ahead and do the back 4.
Are there decimals?
What's that?
Are there decimals?
Then are there decimals?
There.
If you get a decimal, something went wrong. I'm going to pause this. Resume. And unfreeze. Now, again, we've done things that look like this. But when we were doing them before, we were focusing on the angles and the arcs. So remember, it was arc, big arc, subtract little arc, divide by 2 equals angle. But I gave you nothing along those arcs and angles. I gave you segments. So let's take a look at the formula for this one. So I'm going to go directly to a formula. outside. Now I've kind of changed this through the day because I had too many people like first and second have some problems. So in the parenthesis, I'm going to put outside plus inside. But if you add the outside and the inside together, you end up getting the total segment. I'm going to put total underneath. First and second, I just put total, and people are getting kind of confused. The other side says the same thing. Outside, and then outside plus inside. And again, underneath there, I'm going to put total. And then we'll move to some problems so you can actually see what that all means. Everybody good?
Indeed.
So 1 and 2. Now you're going to focus on one segment at a time. I like starting with the x's. So let's focus on this guy. So this guy, when I said outside, I mean the outside piece that's outside the circle. So what's outside the circle on this guy? 9. So 9 is what I'm going to start with. Then in parentheses, I need the total. And to get the total, you add these two things together, which is 9 plus x. Outside plus inside. 9 plus x. And like I said, I kind of changed that about third period because I had a lot of people just putting like 9x and leaving out the plus. So I wanted to get the plus as part of the formula. Then we'll go ahead and close that parentheses. Set that equal to, I'm going to change colors this time, but I probably won't keep changing colors. This side, outside, 10. Then I need the total, which is outside plus inside, 10 plus 17. Well, 10 plus 17, I can go ahead and do that, which is 27. So I'm going to write a little 27 up above that. Now, pretty much everything we're doing today, I just kind of call a plug and chug. You plug things into my setup, you chug out an answer. That's pretty much it. Distribute the 9. 81 plus 9x. 10. This all gave me 27 because this total segment was 27. So 10 times 27 is 270. Subtract 81 from both sides. So 9x equals 189? Yeah. 189. Divide. X is 21. So I get 21. So that tells me that this segment, this one is a 21. Now I had quite a few people get this type of question right also. There was a few more choices that made a better sense. So I think people made some good guesses just because of what the picture looked like. So number 1, are we okay?
Yeah, there's 144 on the next question.
Yes. Like I said, I really liked 144s. They show up a lot. So this side here, outside, and then you're going to get the total, which is 8 plus x. Or x plus 8. Doesn't matter which direction you go. So 8's on the outside. 8 plus x in the parentheses. Do the same thing on the other segment. 9 is outside. Then combine these two things, 9 plus 7. You can put 9 plus 7. If you want to go ahead and combine and get 16, that's fine. Because we know PEMDAS says I need to do the parentheses first anyways, if I can. So 64 plus 8x equals 144. So that's another one of my 144s. Subtract 64. So 8x equals 80. X was 10. Now there's one more like this one, and then you'll notice number 4 changes.
George, 85 minus 49.
Are we okay on these two?
85 minus 49.
Ty, George, we okay on 1 and 2?
Yeah.
George, you good on 1 and 2?
Yeah.
Number 3. Set up just the same. Outside. Outside plus inside. Outside. Outside plus inside. So it's a different setup than the ones we did a little bit ago. Remember the ones we did a little bit ago, they kind of crossed. And we did the 2 pieces, 2 pieces. This one, you do kind of this one, and then both of them. This one, and then both of them. So make sure you don't get them crossed in there. Well, 8 and 13 is a 21 in here. So we get 49 plus 7x equals 8 times 21 is 168. Subtract the 49. I can't remember what that is. 168 subtract 49, 119. 119 divided by 7, 17. So this segment here is a 17. That's 17. Now, 1, 2, and 3. They went all the way out. They went all the way back in. Number 8, I've got one side that does that, and the other side just kind of stops. It stops at the very edge of the circle. Now, the side that looks the same as what we've been doing is the same as what we've been doing. So let's start with this one. Outside. And then again, combine these like we've always been doing. 9 plus x. So that doesn't change. Now the other side, it's still the same formula, but outside's 12. Outside plus, there's no inside because it didn't go inside. It just kind of stopped. So because there's no inside, it's just going to be another 12. So it's 12 times 12.
144.
That's another 144.
Oh my god.
Like I said, I like 144s really on this one. So this one, that side that got cut short. Some books have a whole nother formula and put that as that little piece squared, which is what 12 times 12 is 12 squared. I just hate doing another formula because it's one more thing to kind of remember. So I just teach it the same way. Subtract the 81. So 9x 63, x was 7. Are we okay on number 4?
Indeed.
5 and 6, same set. Outside plus inside. And then what's going to go on the other side of the equal sign?
6 times 6.
6 times 6. Or 6 squared. Same thing. 16 4x. 36. Subtract 20. 5.
Oh my god.
There's another.
Yeah,
There's another one, yeah.
144.
I know. I did not purposely do that. It just kind of kept showing up. 8 plus x. 12 times 12. Yes, you guessed it, another 144. Subtract the 64, I get 80. So x is 10. So on this one, we're looking at if I have segments that go all the way out and come back in, or go all the way out and come in and stop. On these, you want to make sure you're doing outside times the whole thing. Outside times the whole thing. It's not the same things as the ones that cross in the middle. Cross in the middle, it's the 2p's multiply together. The 2p's multiply together. So, same as before. Go ahead and work on it. If you get done, when you get done, I will check it. We'll give a wave to